world of chemistry, and this is digital classes समय 10 से 12 वाला हर घर बनी पाठशाला, and we are studying about the chemistry, and today's topic is collision theory and factors affecting rate of reaction. So dear students, let me tell you about collision theory. First, let's understand about collision. What do you mean by the word collision? Collision word came from collide, okay, in which any reaction, whatever your reaction you are studying, whether decomposition, combination, displacement, double displacement, any type of reaction, those reactions in which molecule must collide with each other. For any reaction will occur only when two molecules will collide with each other, okay. And once molecule collide, they may react together and they may not. It depends. Suppose if I'll take example, let it be take one hydrogen is here in the environment and one more hydrogen is there in the environment. When these hydrogen will collide with each other, strike with each other, then the reaction can be react. They can form H2, they cannot form H2. This depend. Okay, this is the first theory of collision. That is, molecule must collide each other, and once molecule collide, they may react together or they may not be react. Second, molecule must have sufficient energy. Molecule must have sufficient energy to react. Third, molecule must have correct geometry. Okay, like O3 is ozone, NO is nitrogen oxide, nitrous oxide. When it will react, it will give oxygen 2 and NO2. So O3, you know the structure of O3. O3 will react with NO. It will form, how it will react. You can see the step. So this must have correct geometry. This is wrong. Suppose the second one is wrong. First was incorrect because in first one the geometry is there. O3 converting into O2, whereas you can see here OON is not any formula. Okay? Then after this, if we will talk about collision theory, the collision theory is somewhere it is related to temperature factor. So factor affecting rate of reaction we studied. So temperature and rate of when we are going to compare temperature with rate reaction, then we are discussing about the collision model. Okay, so reaction occur when molecule undergoes collision. All collision are not affected. Collision of molecule with sufficient energy are only effective. So what is those molecule which is effective, which have effective collision? Number one, first thing you understood, reaction only occur when the molecule were going to under collision. Second, it is not necessary that every collision will form a reaction, form a product. So those collision which will not form product, that is not known effective collision. Only those collision are known as effective collision which form you can say the with sufficient energy, okay, which is called effective collision. So effective collision is what? Collision which leads to the product formation by government of two factor. Due to these two factor, reaction are formed with the collision. Number one, orientation barrier. Second is energy barrier. Orientation barrier is what? In which reactant must collide in favorable orientation to make a break bond. Okay, orientation मतलब किस साइड से जो है वो मॉलिक्यूल टकरा रहे हैं, जिस साइड से वो टकराएंगे उस साइड को उनके बॉन्ड बनेंगे. एंड एनर्जी बैरियर इज विच साइड द मॉलिक्यूल having energy greater than the equal or threshold energy. So threshold word is there. Threshold energy is minimum energy that required to make a bond. And when bond is formed, again chemistry क्या बोलती है? Chemical bond will form when one atom is releasing electron and other atom is accepting electron, or there is sharing of electron. There is the chemistry of sharing of electron. Only then the that chemical reaction will form. So threshold energy is that minimum energy which help the electron to remove from outermost shell. Okay, so here you can see before collision molecules are like this way, and after collision molecule will having effective collision, and after collision it will form this kind of molecule. But in case of ineffective collision where there is no product, so product will not form any reaction. This will remain same as it is that the reactant is there. Okay, तो मेन बीच में वो कोलाइड होंगे लेकिन वो फिर से वैसे ही बनेंगे जैसे रिएक्टेंट थे. दैट काइंड ऑफ कोलिजन इज कॉल्ड इनइफेक्टिव कोलिजन. बट इफेक्टिव कोलिजन इज व्हाट वेयर अ न्यू प्रोडक्ट इज फॉर्म्ड. ओके, सो नाउ व्हाट इज थ्रेशोल्ड एनर्जी एंड एक्टिवेटेड कॉम्प्लेक्स. अब एक्टिवेटेड कॉम्प्लेक्स क्या है? एक्टिवेटेड कॉम्प्लेक्स इज एक्टिवेटेड एनर्जी. इट इज द एनर्जी बैरियर टू द रिएक्शन. हियर वी स्टडीड एनर्जी बैरियर. So here we will study about the first. We will study about the we need minimum energy to remove the electron from outermost shell, that is called threshold energy. And when it is moving, the electron is moving, atom is moving to highest stage, one top stage, that stage is called activated energy. So energy barrier to the reaction, amount of energy need to convert reactant into activated complex. Okay, it is the reaction that required to, it is the energy that required to convert reactant into activated complex. The activated complex is a chemical species with partially broken and partially formed bond. Okay, for example, if I will tell AB will react with C, so A will not react with C. A will not react direct with C. First bond between A and B will partially loose and bond will form with C. Later on what will happen then? A will break down now and B and C will form bond. Okay, in this way the reaction will occur. So that complex which is between reactant and product is called activated complex. Next is, there are, for example, take an example, A plus B will react and form C plus D. So there are two type of reaction. Exothermic reaction. In exothermic reaction, when AB is going to be react and form C and D, then A and B's energy, the energy of A and energy is B, it will increase the energy level, and one extreme level, when it will increase up to extreme level, that extreme level is called activated complex. That extreme level is called activated complex. दोनों केस में activated complex उस extreme energy को बोलते हैं. And this is recognized by EA and EA. So in case of exothermic, the activated complex, yeah, you can say energy of reactant is less than the energy of product. Whereas in endothermic, reactant energy is more than the exothermic reaction. Okay, so the activated energy is what? It is the minimum amount of energy required to initiate a chemical reaction. It is the minimum amount of energy required to initiate a chemical reaction. So reaction mechanism we will discuss. The overall progress of a chemical reaction can be represented at the molecular level by a series of simple elementary steps. For example, the sequence of elementary step is like this way. We will take example of this. 2NO will react with O2, form 2NO2, in which 2N2O2 is detected during the reaction. Now in between there somewhere N2O2 will form, like elementary reaction NO. 2NO will react, it will form N2O2. Then N2O2 will react with O2. Then N2O2 plus O2 will form NO2. So you can see this is the central activated complex product. Later on the reaction will become like this. So this complex N2O2 is the activated complex here. It is EA. Okay. In case of intermediate are species that appear in a reaction mechanism but not in the overall balanced equation. An intermediate is always formed in an early elementary step and consumed in a later elementary step also. So this is called elementary step. The molecularity of a reaction in which the number of molecules are reacting, it is of three types: unimolecular, bimolecular and termomolecular. Tertiary molecular, you studied it is in molecularity. So number of molecule which is participating is called molecularity. If molecularity elementary step is one molecule, then it is unimolecular. If two bimolecular and three step is there, tertiary molecular. Okay. So this is all about collision and activated complex. Now factor affecting rate of reaction. So dear students, you already studied that there are 5 factors that affect rate of reaction. Number 1, nature of reactant. Number 2, surface area. Number 3, concentration of reactant. Number 4, temperature. Number 5, catalyst. So one by one. First, nature of reactant. Rate of homogeneous reaction is higher than the heterogeneous reaction. Number 2, rate depend on the physical state of reactant also. Maybe it is liquid, gas, solid. So solid will react very slow, gas will react very fast. Rate depend on the number of collision or number of encounter between the reacting species also. So try to understand all these logic, that how rate of reactant will change, yeah, speed of reaction will change with the nature of reactant. Okay, it depend upon homogeneous, heterogeneous, it depend upon solid, liquid, gas, it depend upon the number of collision. Second is surface area. Heterogeneous reaction occur at interface of two phases of reactant. If one reactant is solid, rate increases with the increase in surface area. Whereas in other case, surface area increase, area of contact between reactants increase, rate of encounter. It means that more the surface area, more will be the rate of reaction. Third is concentration. Reaction molecule must collide with proper orientation and sufficient energy. We studied already in collision theory that above factor increase as concentration increase. Rate of reaction will increase with the concentration of reaction. Okay. Temperature will also increase with the rate of reaction. Suppose temperature is what? Temperature increase kinetic energy, movement of particles. If more the faster movement of particle, more faster will be the collision. It is simple. Kinetic energy increase, temperature will increase, kinetic energy will increase. If kinetic energy will increase, the speed of molecule will increase. If speed of molecule will increase, the collision will increase. That is increasing the collision frequency, hence the rate of reaction will also increase. So last is catalyst. Presence or absence of catalyst will also affect the rate of reaction. A substance that increases the reaction rate without undergoing a chemical change is called catalyst. Provide an alternate reaction mechanism, faster the mechanism in absence of catalyst. Lower the activated energy for a chemical reaction, lower will be the rate of reaction. Okay, so what catalyst is doing? Catalyst is decreasing the path. Just suppose you want to go from here to Kullu, and you have two ways. Number one, you will go by Patlikul. Number two, you will go by Nagar. Now you know by Nagar it will take too much time. It will take more time. Ultimate destination is same. Suppose you are moving from Manali to Kullu, and you are going by Patlikul, and this is you are going by this is upper one, you are going through Nagar, and this is you are going through Patlikul. So obviously catalyst is what? Catalyst is what? It will decrease the path of reaction. It means that product we are getting easily. Okay, suppose I will take example. If you want to go, suppose from Rangdi to Jagasuk, and if you are going through Aleu, it is taking too much time. If we will make one small bridge from Rangdi to direct to Prini, that will decrease your time. Okay, the moment catalyst is doing what? Catalyst is decreasing the time of rate of reaction. So because of that, the rate of reaction will increase. Okay, so these are the following factors. One by one. Increase in temperature. Conclusion: increase in temperature increase kinetic energy. Kinetic energy increase the number of collision. Number of collision increase the number of particle with greater than required amount of energy, and it increase the more particle react, it increase the rate of reaction. Second, it can be explained why food should be kept in deep freeze compartment in order to ensure freshness. The low temperature slow down the chemical reaction, which makes the food turn bad. Concentration and pressure: high concentration pressure, more particle per unit volume, it increase the frequency of collision, and it increase the rate of reaction. Surface area: increase the surface area, increase the exposure of other reactant, increase the probability of collision, increase the rate of reaction. Next is catalyst. It speed up the rate of reaction through lowering activation energy needed the reaction to occur. And what you think about that? What can you infer from the above statement? So these are the today's topic. Hope so you understood. Today we did about the collision theory, from collision activated complex, then factor affecting rate of reaction. So this is all about for today, dear students. Hope so you enjoyed this video and you understood this topic. So please make notes from this topic. And now last topic left from this chapter, that is numerical related to order of reaction. Okay, so thanks for watching this video. Stay home, stay safe, take care of yourself, take care of your family also, and keep enjoying these digital classes. Thank you. Have a